All right, so now let's do an analysis. We'll start with a transient analysis because we have a signal generator and we want to plot this analysis of this RC circuit over time. So what we need to do, if we just want to run the simulation, it'll tell us there's no analysis command found. It doesn't know what to do. The way to do that is, again, right click and we'll go to draft, and we need a spice directive. So we'll do this, and this is where we type in our analysis command. And if you don't know what to type in, you can also right click and says help me edit the analysis command. So okay, let's perform a nonlinear time domain simulation. That's the transient. And since we remember that our pulse was 20 milliseconds, let's make this at least 100 milliseconds long. We'll see several of those pulses, and that's all we time to start saving. You could say you can start at time 0 if you wish. So that's our directive. We could say OK, so it writes our code for us, and now we say OK, and we just need to place this anywhere in the schematic, anywhere in the drawing. It doesn't need to be anywhere particular, it just needs to be on there. So you could just move it so it's out of the way if it was ever in the way. So now we have our spice directive. Now we can run our analysis, and it brings up a little window here. On the Windows version of this program, there's lots of buttons so you can tile these or cascade them. On the Mac version, it just brings up another window that we can just place wherever we want. And of course, it's blank now because it doesn't know what to plot. And when we go back over our schematic, you can see these little voltage probes that can probe different places. You can probe over a component. We could do that. That's, of course, plotting the voltage over that component. Let's see. Delete. Can I yeah, I'll delete that plot. Okay, so what I really want is I want to plot the input of this RC circuit. So I'm going to go over here to our input node and click once. And now we see our square wave going on there. Press escape to get out of my cut mode. So I can see the voltage. If we had named this, let's say net name, and this is my input. We're going to put this as the input, and net name output. So I'm labeling my nodes. So now when we go to run this and plot our input, we now see this is the voltage into the filter. So there's our square wave. Looks good. Let's look at the output. Not sure what happened to my net. Did I undo that? Net name. Doesn't really matter. I don't have to have it. It's just kind of nice to have a label there. We'll do that. Press escape. And I'm going to look at my output. So there's the output of my RC circuit. So that's the capacitor reacting to the input pulse. So we have and we can see that it's 1 volt tall here. We could, of course, if we go over our plot again and we go over a component, now we get this little current meter. So I can see it'll measure current and it'll show you the direction that it's looking at current. So we could also look at current through our capacitor. And we can see there's the I of capacitor. So these are all starting to stack up. We can add a plot plane. I could just let's just do a different configuration here. Put it over here. Maybe I'll make this a little smaller. Again, it doesn't really matter, just how you like to look at things. I'm going to right click and I say add a plot plane. Let's add a couple of plot planes. There's a couple of plot planes. Now I just take my mouse and I drag these. I'm clicking on the label and then dragging it. So now I have all of these in different windows. You do notice that when you have, let's say this one, put this one back over here. We had the first scale was over here, and of course we can right click on that and change our scale. But you can see that when we had a different scale, it'll show up on the right, and we can say, we can change that scale as well. But let me drag that one back down to its own little plot plane. So if you want to compare things pretty easily, you can drag them on top of each other. If they had different scales, it's kind of nice to see the different scale of your response there. So that's our plot planes there for this circuit. We have our input, our output, and some current. You can also add a cursor, and I believe I just, click to attach cursor, right click to edit. So I can right click to name the expression there, but if I just click once, then I get a cursor, and you get this little box that'll show you exactly the values of the cursor, and I can take my little hand tool and move my cursor over different spots, and I'll tell you that yes, I'm at 1 volt now, and I'm at 0 volts there. I'm going to click on my voltage there. So now I have 2 cursors. One is doing the output side. So there's on my output side. It eventually gets up to a volt, or nearly a volt. If I had a few more milliseconds, it might get even closer to a volt. But they're from 0 to almost a volt, and then back down to 0. So we can see, so we can start doing comparisons between different parts of our waves. We could even have 2 cursors in the same plane, so we could have one there, and we can do comparisons between each one of our cursors. So there's a lot you can do in the analysis window, adding plot planes, looking at cursors, instead of just trying to figure out what the voltage is by just looking. You can actually place a cursor and get the exact voltage measurements.